Ladies and gentlemen, it's my mixed pleasure of taking you away from lunch bites, coffee, conversations, innovation. The good stuff happens in the breaks. That's where the good stuff happens. I am the bad guy. That means we start. So please come back into order. The next speaker is going to provide an industry review on what's happening in automotive robotics. His name is Alexander Zek, and he is the Director of Corporate R&D at Magna International. You may not all know about Magna, but if you drive a car in the US, you will be using Magna technology because they produce a lot of the parts and core parts too for a lot of the big car brands in the US, among other things. So Alexander, stage is yours to let us know what's next for automotive robotics. Thank you.
Thank you. Hello, everybody, and thank you for giving me the opportunity to give you an overview about automotive robotics and how I see robotics needs to evolve to get more and more into high-volume manufacturing. We saw a lot of interesting talks today, and also products are coming out. So all these products need to be manufactured somehow. So I want to show how we see robotics evolving into the automotive industry and into automotive production. So here are some key facts about Magna, just to show that there's a lot of power and potential behind the company to do stuff and change things. Here's a little bit, like the introduction already said, these are all the product groups we are producing, from little brackets up to full vehicles assembly for various customers in all over the world. This is also a differentiator for Magna to other suppliers, that we have the full vehicle understanding on the engineering side and also on the manufacturing side. And some newer students I interviewed, they said, I want to rather go to Stanford or to work for one of these startup companies. Automotive is not so sexy anymore. So please think about the product, the reliability, the requirements on your vehicle. If a cell phone goes down a day, if a car doesn't start in the morning, you have different feeling about that. So what's innovation for us is it's not because it's cool. It always has the laser focus on getting commercialized and should help us to become better and more efficient. What our drivers is, of course, the global megatrends nailed down to the point that everything needs to be more affordable. That leads into what I'm doing with advanced robotics in my field. And as many of you know, that this pressure on producing faster, cheaper, more flexible is all over the world, in China, in Europe, in North America. Every country has its initiatives to bring up Industry 4.0, Smart Factory, all these initiatives, governmental funded initiatives to increase the manufacturing footprint in their country. So these are the 9 enablers as we know them. I highlighted the one which I'm focusing is the autonomous robotics, how I call it. My partner department, my peers, they're working on autonomous driving. I'm focusing on autonomous manufacturing. So this is how manufacturing looks today. We saw a couple of pictures already earlier. So robots are encaged, parts are fixtured, and robots are doing tasks which are very repeatable. They need to be very accurate, very fast. They have to carry heavy payload, but they are not very adaptable, flexible, or can do human-like tasks. From the other side, is the virtual world coming with augmented reality and virtual reality. I think there's a big steps going on, but also it's getting closer and it's getting together. But this is more the other end, and I see what I'm doing on a production cell, and the virtual world will meet at one point of time. They have to meet at one point of time, and I think then we'll have a really breakthrough event in manufacturing. And I think social models need to change, employment models need to change. It will change the world. This explains very simplified what I'm doing. So I'm taking the human senses, what we developed over 100 millions of years, and now I'm going around the planet and looking for technologies and to stack them to duplicate these senses, but not like general, like our human body is created. It's more with the focus on assembly tasks. So it's a little bit more narrowed. It's not that broad. So on this, I'm working with startup companies. I'm working with universities. I'm working with all over the world with different models on companies and universities, from one-man show to large companies. So everything needs to fit to enable that model. Also, Magna needs to be adaptable and flexible with working with everybody. You cannot push systems into little startups. You need to adapt and see how these startups work. So here's my focus area on R&D. Adaptability, flexibility, and human-like dexterity. How can that be duplicated and implemented into robotic systems to make them do tasks which only humans can do today? And some of these tasks are really harmful or really hard for humans. And in my mind, it should change. This task should not be done by humans anymore. Humans should do better jobs and better work and have better jobs. This is various R&D areas I'm touching and we are executing right now in-house and outside. Mostly that the model is that we do proof of concepts on a technology outside. And if it meets the criteria, then we integrate it on one of my R&D cell in-house. And we do, of course, key for high volume production is robust processes. So then we do intensive reliability, repeatability studies. This is normally the work that's not so interesting for the scientists. This is when then the engineers are coming in. This is one example right now. This is you see a little bit that this is a front fascia on a car, the bumper, also called. So here we are using adaptable vision technology to find the part, first to find the pin, find the part in the pin, and pick it out and place it on the silver fixture on the left side on the picture. And this is all vision guided, and we want to have that system not only see one part, it should see many parts. And yeah, this will increase the productivity significant. And also to show that it's not only tests and trials, I'm also very proud to say that we have systems already launched in production. These adaptable, flexible systems, vision-guided robotic systems are in high-volume production. We are picking unfixtured parts. The parts you're seeing, they can shake around in the bin, but the system will find them and place them into the manufacturing machine on the rear side. And this is now going since a couple of weeks. Yeah, this slide also concludes my presentation. So I wanted to give you an overview of how our industry is working. We want to transform the robots from rigid systems to more adaptable, flexible systems with human-like dexterities. And we are open to collaborations any type with startups and universities. So if you have a technology that you want to bring to us, yeah, feel free to reach out to me, and looking forward to, it's an exciting time, yeah. It's really exciting. Thank you.